In today's video, we're going to talk about the configuration of analog sensors and configuration of analog fuel level sensors. The key feature of analog sensors is that by disabling and enabling ignition by the value parameter from which the data is taken, messages with inaccurate data are transmitted for a few seconds until the necessary value is reached. You need to remove the period with inaccurate data. In case if the data from analog sensor is transmitted by parameter IN asterisk ADC asterisk, where asterisk is the input number, we can use it directly. Otherwise, we need to create a sensor with you. To do this, let's go to Sensors tab in the unit card, press Add, choose the type Simple, sensor type is Custom, and the input type is Analog. Also, we set the alias. In this case, we have fuel. By creating not just a sensor but a fuel level sensor, we go to Sensors tab, press the button Add, select the type Virtual, sensor type is engine is fuel level correspondingly, and the function is expression. The function expression allows us to create a formula. In the formula, we create a function that checks two conditions: enabled ignition and speed that is higher than specified. So now I inserted the needed formula. The function allows to remove the period when in the analog sensor inaccurate data was coming. Now let's see what this function means. Here, IGN letters mean the alias of ignition sensor. This part means that it is the checking of the condition that the average speed of a unit between two messages is more than 15 km per hour. The average speed between messages is calculated to decrease the fluctuation influence of the speed that appears due to signal distortion during stops. ADC2. This is a parameter from which the fuel level sensor values are read. Earlier, we created a custom sensor with alias fuel that can be used in this formula instead of ADC. So, remember we used the alias fuel, and instead of this, again, you will see the name of that already created custom sensor. In this formula, we can change speed. The higher it is, the more acceleration the vehicle needs, so as the data is taken into account. Also, we enable median filtration that allows to smooth the chart and get a lesser fluctuation of fuel. So, and calibration type is table here. Also, we can click Show Last Valid Value, and we can add the calibration table that we need. For example, here, let's take 100, and here 64, output 8000 and 0. And we will see such display of a calibration table for this fuel level sensor. We press Save. Now we can see that this fuel level sensor is added into the sensors list. After configuring the fuel level, we need to perform the setting of templates, fuel fillings, and drains. We go to the templates, and here we can see drains and fuel fillings, already created templates. After the configuration of fuel level has been done, we go to this setting of templates, fuel fillings and drains. They are in Templates tab. We click to the fuel fillings. Here we have the pop-up window, Editing Template. The settings of fuel fillings and drains templates are the same. First, we go to parameter time, and we need to change it into 1 second. This way, the sensor will be more sensitive to any fluctuations. If some fillings are not displayed, set value 0 or delete this condition at all. Now we click on this parameter. Note that we must have with you one basic condition. If you have here the parameter stop 150 meters, you must delete it. On this example, we don't have this parameter, so it's correct. We must have only the sensor here, the parameter fuel level. When you delete the parameter stop from this window, it helps you monitor fillings and drains in case if event stop is inactive. So we should have these settings. We press this, press save, and the data has been saved successfully. Thank you for your attention. Subscribe to our channel and visit us for further information on our official website. We will be happy to see you in next videos.